There's a file in MyOpenMath. It's in sampling distributions and confidence intervals. It's that first one there, the CI. And we're going to make confidence intervals, and we're going to put them on the sheet. So for this data, we got 30 observations, and this is from a normal distribution with a mean of 50 and a standard deviation of 18. And at the bottom, erase those, we'll start them again. We're just going to get the average, the standard deviation, and the standard error of the mean. So at the bottom, next to the average, use the automatic command or just type in average. And the average is 48.9, which is pretty close to what it should be. The standard deviation is equal STDEV dot S. That's a little creative. And just mark the numbers. And the standard error. You remember what the standard error is, what the formula is. It's the most complicated formula in statistics. Divide the standard deviation by the square root of the sample size. So here we want equals, and divide that standard deviation by the square root of 30. This is the difference between betting on an average and betting on an individual. If we bet on the average, we've got a plus and minus one standard deviation of 19. If we bet on the average, we have a plus and minus standard deviation of 3.5, which is a whole lot better bet than the first one. Right, up here at the top, we're going to make 95%, 90%, 80%, 68%, and 50% intervals. So what, and we've got a t distribution with 29 degrees of freedom, what probability do we need to use to get the t value for these things? For a 95% interval, what is the probability you need to look up? You can use one of two. There's the middle. And we want 95%. We need to look up this end or this end, and it's always the probability coming from the left. So we could use the probability to there or to there. So which one, pick one. Which one is right? Which one do we use? What probability do we use in the t.inv function? 97.5. That would be this one. This one is 2.5. If I used 2.5 and 97.5, what's the difference in the values? One's positive, one's negative. So I need to find for these probabilities. I'm going to use the upper end. So for this is 0.95. I need to get a 0.975 so I can do the calculation easily. Let's put in 0.975. What about the 90% interval? What is the value I want on the upper end so I get a positive number back? 90% in the middle. How much on each end? 5. So I've got to go 5 up to the 5 and then 90. So where are we? 95. 0.95. How about the 80%? And if you ever get confused, just draw a line. Put 80% in the middle, 100% all together. How much is in one end? 10. So I've got to come up 10 and then go 80. So this is 0.9. For the 68% interval. 68%. %68 in the middle. What's on the outside? Altogether. 32 altogether. 16 in one. I add the 16 and the 68. This is 84. And that's all there is to do in these things. You want to find the probability, you just draw a picture, take the numbers that you get. So this is 0.84. What about for 50%? 50% in the middle? What's on the low end that I have to add? 25. So this is 0.75. And I'm only doing this so I only have to enter the command once. The command for the t distribution. Instead of the z, I have to use the t, equals t dot inv. And it pretty well tells you the rest of what it needs. It wants a probability and the degrees of freedom. The probability is just the one that we got, because it's always coming from the left. The degrees of freedom. How many degrees of freedom? Sample size of 30. 29. It's always n minus 1. So we've got the probability, comma, and 29. Close it. And there is the t value we need for the confidence interval. If this were the standard normal, we would have 2. Because it's a t distribution, it's a little bit wider, so we get a little bit more than 2. So this is the t value we need. And if we copy this down, what's going to happen to the t values as my intervals get narrower? As I come in from the outside, what happens to the t value? Get bigger or smaller? For the empirical rule, 95% is 2. What's 68%? 1. So as I copy these things down, they're going to get smaller. The 50% interval has a 50% chance of catching the average, the true average. 68% is a little wider. 80%, 90%, 95%. Right? And if you ever have to do a confidence interval for somebody or tell somebody what you want, always tell them 95%. That's just what they expect. You say 95, everybody's happy. If I said 94.5, somebody wants to know why. So here, this part of the formula is where I have the average minus the t-value times the standard error. That's down. And the average plus the t-value times the standard error. And that's up. This is the lower limit and the upper limit. And it's written like this. In this formula, the t times the standard errors, how many standard errors up and down I'm going to go. This is called, it actually has a name. This is called the margin of error. And it's just how far up and how far down we're going. Because it's the same for both subtract and add, it's usually easier just to calculate the margin of error outright and then add and subtract it from the average. So for this is the margin of error. And you've seen margin of error a lot. When they do an election poll, they say 53% with what? A margin of error of plus and minus 3%. That's actually a 95% confidence interval that they're quoting. That's where the 3% comes from. And that's for proportions. We've got to do that a little later. But for this, the margin of error is the t-value times the standard error. That's it. So in each of these, I want equals, and I want t times, and then I can go get the standard error. And there's the cell reference, C37. So the margin of error is 2 standard errors up and down. The standard error is about 3.5, out 7 each way. And if I copy that down, what's going to happen? I want each of these to be t times the standard error. What did I get? 0. Is it 0 really? No. In this formula, this reference to the cell is C38. The cell I was in for the standard error is C37. And I need to lock that cell so I can copy it without moving the reference. To do that, all I need is a $sign in front of the C and in front of the 37. I can lock rows and columns individually with a $sign. Here I've got it, so no matter where I move this formula, it's going to multiply by whatever's in C37. And the reason this hasn't got some kind of fancy symbol or something to lock the cell is because the guy who invented this stuff had an old IBM Selectric keyboard. And he had to use what he could get. So I get the same number, but now if I copy down, I get how much I'm going to go up and down for each confidence interval. So I need to calculate it. Put in here lower limit and upper limit. This is where the formula average minus the margin of error and average plus the margin of error comes in. So for this, I've got the margin of error. I've got t times the standard error. So I want the average minus this and the average plus that. So for this one, it's equals, and I need the average, 48.9, and I'm going to subtract the margin of error. So the lower end of the 95% confidence interval is about 42. The upper end, average plus the margin of error. So if I go 7.3 down from the average and 7.3 up from the average, I get the 95% bet on the average. I want to copy this formula down. But to do that, I have to lock the reference for the average. I want it to stay in C35. So I put a $sign in front of both of those. And it will not change. No matter where I copy that formula now, that cell reference will be there. And I need to do it for the upper end as well. All right, I've got these. And I copy them. Right, then on this sheet with the graph, here we got a line and it goes from 40 to 60. And we're just going to graph the confidence intervals. 50, 55, 45. The graph has better positions on it. But the first interval, what's the lower limit for the 95% interval? 41.6, and it goes to 56.2. So here, about 42, I'm going to make a line, and it goes to 56.2. 56.2, somewhere here. Draw a box there for the 95% interval. That's the 95% bet. We're betting 95% odds that the true average, which is 50, is in that interval. And we got it. It's not going anywhere. What about the 90% interval? We want to draw the 90% interval on it. The minimum is 42.8, and it goes to 54.9. I'm going to stack these on here. 42.8 to 54.9. And that's the 90% interval. What's the chance that the real answer is between the upper end of the 90 and the lower end, the upper end of the 90 and the upper end of the 95%? 2.5%. and 2.5 here. All these are pieces of 100. And we know that the confidence interval is always in the middle. So this is where me and the rest of statistics get sideways. Right. To me, I don't care about 95 or 90. It's what's the bet. So if I'm buying something and I buy it for $50 and it's actually worth $55, did I lose? If I pay $50 and it's actually worth $40, then I've lost. So to me, one side of the confidence interval is important, depending on whether you're buying or selling, and the other end is just entertainment. Because if I can get 55 for the price of 50, I'm good. Where I lose is on the other end. So I've always tried to tell people, look at both ends, but you don't need to use the same ends. Here, this might be important, but this one I can slack off on. Or just the opposite. One of them is more important than the other, because all of this is based on a cost plus loss basis where this side is as bad as that side. Here's the 95% interval. It is just as bad to be here as it is there. But if I'm buying, if I could get up in here and pay that, if I'm selling, it's the other end. All right, the 90% interval we got. How about the 80%? 44 to 54, basically. Whatever it is, it's inside. The 68. I got more stuff here than I need. The 68% interval is 45.3 to 52.5. 45.3, whatever it is exactly, it's inside of that. And look at the margin of error for the 95% interval and for the 68% interval. How big is the margin of error for 68 compared to 95? This goes back to the empirical rule. Plus and minus 2 is 95, plus and minus 1 is 68. Literally, 95 is twice the 68. And if you look at this compared to that, it's still twice. So if you have a 95%, cut it in half and you've got the 68%. And it's always that way. The 68 and the 95 always have the same relation in a normal distribution or a t-distribution. The last one is the 50%. 51 on the upper end, 46.4, whatever it is, it's inside that. That's my confidence interval stack. If I drew a smooth line over the top of that, what's it going to look like? It's going to look like a normal distribution. That's where all these things come from. Or a t-distribution, which it may as well be a normal. So that's how these things compare and how you can make bets based on different intervals. If I really don't want to buy this thing, I don't want to buy this property, but if I can get it cheap, I'll take it. Where am I going to bet? What's my bid? Lower. I could go here. I still have a 25% chance of winning because it's 25 to there. But if I don't get it, I'm not upset. If I do get it, we all have a party. So in confidence intervals, they're always plus and minus the same amount. But if you're using a confidence interval, you've got one end that's more important to you than the other. And that is completely at odds with typical statistics. All of this stuff, don't let statistics get in the way of what's really going on. Nobody does this. They don't say, oh, it's 41.6 to 56.2. What they do use is a percent margin of error. This is why the margin of error itself is important. For each of these, I want to take the margin of error and divide it by the average. So, this is equals margin of error divided by, and I believe that was in C35. And I've locked the cell reference so I can copy it around. C35, I got it right? Oh, and I want to multiply it times 100. That's always in a percent. So that this confidence interval isn't 41.6 to 56.2, it's plus and minus 15%. So if I have the average, I can figure out what 15% of that is, and it's going to be the margin of error. So this is how big is the margin of error compared to the average. And if I said 41.6 to 56.2, you've got to have a context. You've got to know what's going on. If I say plus or minus 15%, everybody's got some idea. We don't need the exact numbers. Right? So when people want to specify an answer they want, they will inevitably say plus and minus 10% with 95% odds. From that, I can work backwards to what I need to get there. But confidence intervals are given usually as percents. So this is a 15% plus and minus. And it's always plus and minus. It's both ends. If I copy this down, this is the percent confidence interval for each of these levels. Look at the 95 and the 68 again. What's the 95? What's the 68? Plus and minus 15, plus and minus 7.4. This is twice that, or this is half that, however you care to think of it. So when you get 95%, which is the typical request, you can get 68 and figure up other odds immediately. No calculation. On the graph now, we've got the actual numbers. What we need is percent confidence interval. Minus 20 to 20. Minus 10, plus 10, drawn absolutely to scale. First one is plus and minus 15%. Here's 15 down and 15 up. That's 95% bet. The percentages start to stack up. It's a 95% bet, and it's plus and minus 15%. What's the 90% bet? 12.4. 12 down, 12 up. That's 90%. 80% bet. What do we got? Plus and minus 9.6%. Right there at the 10. What else have I got? 68%. That's going to be half the width of the 95. And the 50% bet, the last one, is 5. 5% up, 5% down. This is the percent version of the actual values that nobody uses. The 95% bet is on plus and minus 15% of the average. So the average, the true average, is between the sample average minus 15% and the sample average plus 15%. And they all go exactly that way. Also, all of these things are the same. Here, I'm looking at it from one direction. This one, I look at it from another direction, because nothing changed except the t-value in each of these. I can make a 50% bet, but I'm also making a 95% bet, and every other possible bet. So that this is really difficult to get people to accept that the only thing that changes is the odds. So if I want to make a 15% bet, plus and minus, I'm actually making a 5% bet, plus and minus, at the same time. Because nothing changed except the way I looked at it. So if you imagine, I think I mentioned Father Ted and the sheep. We're way back looking at the sheep. They look small. As you move toward them, they get bigger. Did they grow? Same sheep. Exactly this. So here, I'm standing way back. Here, I'm getting closer.